Okay, first of all, this week I want to thank everybody for the increased listenership last week. We got a huge spike based on the interview with Paul Schreiber. He's apparently quite a popular figure, and a lot of people seem to really enjoy the podcast. This week we're going to be talking with Randy Jones. This is a continuation of our Muff Wiggler special month, where I kind of comb through the forums at muffwiggler.com and find out who are some of the more controversial or active or interested or interesting people in the community, and try and engage them in an interview. So far, so good. In this interview, I will probably sound a bit like a fanboy. It's because when it comes to Randy's work, I'm kind of a fanboy. I think the Soundplane is one of the most intriguing hardware interfaces for synthesis that I've run across. Really phenomenal work. The Aalto software, as you'll hear in the interview, is something that I not only use, but I actually use as an exemplar for people who are thinking about getting into modular systems. If you haven't tried the Aalto software, you really deserve to treat yourself with that. And as far as the Soundplane, I don't know how easy it'll be for you to get near one, but I think you'd really find it interesting if you could run across it. So give yourself a chance to interact with some of Randy's work. I think you'll like it, but also check out this interview. I think we go into some really interesting detail about how it is that he does what he does. Here we go. Okay, in today's interview, we're speaking with Randy Jones of Madrona Labs. Randy is a longtime participant in the media arts in general. He's been involved in a lot of projects across the landscape, but in this interview, we're specifically going to talk about his work with the Madrona Labs company that he started, and with the balancing work that he does with hardware and software development. Randy, how are you doing today?
Pretty good.
Why don't we kick this off like we generally do in these interviews by having you give us a little bit of background?
Okay. Well, you mentioned Madrona Labs, so maybe it's easiest for me to work backwards a little bit. And then maybe I can work forwards again. I don't know. We'll find out. Because currently I'm spending full time at working in the context of Madrona Labs, which is a company I started in 2008. So I've been doing my thing full time for 3 or 4 years now. And that is, as you said, making hardware and software for electronic music. Right before that, I got the idea to start the company based on just kind of where I was at, and the fact that I'd finished a graduate degree at the University of Victoria, and I made this thing called the Soundplane, which was in the context, it was a big part of my master's project at UVic. And this was a prototype of a multi-touch pressure-sensitive surface. The Soundplane was it was an attempt to make a new version, a thing that a couple people had been chasing, and I knew about these other ideas for making pressure-sensitive controllers, and we can get more into detail about it later. But it was a vision that I'd been kind of chasing, or put more directly, an instrument I wanted to have since at least 2000, when I'd fooled around with some other really early implementations of that kind of a thing. And I just thought, I'd been thinking for a long time it would be such a great controller for electronic music. And before that, I was, as you know, working for Cycling 74 for a little while on the Jitter project mainly. And I think it was a pretty, when I was working on Jitter, it was with Joshua K. Clayton, of course, and with Jeremy mostly. And I was responsible for coming on and doing the OpenGL stuff, essentially, because I'd been working in the area of trying to combine sounds and visuals and do real-time performance for quite some time of electronic sound and images at the same time. And there, culturally, there's a real rich history to draw on there that I was really starting to learn about at the time and excited by. Technologically, it was just becoming possible to do that kind of a thing with your own computer, but only if you worked using OpenGL, so that the CPU didn't have, because the CPUs were, just capable of pushing around enough audio for people's uses at the time. So this was really sort of the birth of people being able to do a lot of cool stuff around that time. And before that, we're getting into, I just had a long-standing interest in electronic music for whatever reason. I guess to go into that would be difficult to understand, maybe. But my parents had a cool record collection. That's probably one aspect of it. But I remember I always used to go to the library. I'm from Madison, Wisconsin, which is a college town, and my dad worked there. So there was some way I could get into he could get me a staff pass to the library. And I remember I was always going and checking out books on electronic music and things like Bernie Hutchins' Electro Notes series. I guess you'd call them fanzines now almost, but this is a highly technical fanzine.
Well, it's actually interesting you bring that up, because I just got done interviewing Paul Schreiber, and a lot of our discussion there was about how important Electro Notes was to his developments as well. I mean, it's really an amazing piece of work, and amazing that you can still get them. Bernie Hutchins is still selling them.
Yeah, that's really great. What can I say? That's great.
Yeah. And so
I haven't been too active in hardware synthesis design, because it was, I was interested in all this stuff and made a few circuits or whatever. Sort of know enough about electronics now to be dangerous, but around the same time I was checking that stuff out, I got my first personal computer, which is VIC-20, and made just a ton of weird programs for that to kind of play with sounds and visuals. That was one of my favorite things to do when I was real small. So, the software, of course, never really thought about it then in a kind of abstract way, but I guess all along the possibilities of software have seemed more open-ended.
Sure. Did you say your first computer was a VIC-20?
Yeah, it was. Yeah.
Oh, that's outrageous. So you got sort of like entranced by very blocky video to begin with, huh?
Mm-hmm. For sure.
Because that was one of the early computers bouncing around our home as well, and I just remember it's kind of funny for me, at least now, to see sort of like this enamorment with sort of like 8-bit audio and the really crunchy video, when at the time we would do anything to dull the edges of those great big pixels,
Yeah. Well, there wasn't even that much you could do to
right.
But yes, absolutely. I remember trying to dither images, on a screen that was, I forget what the resolution was, but probably like 200 by 80 or something like that. So pretty funny stuff to look at.
Right, indeed.
Great amount of nostalgia for a lot of people around my age.
So let's talk a little bit about the Soundplane first. My first interaction with it was when I was actually at Cycling 74 office, and I had heard about it and seen pictures of it, but to my first touch on it was one that we had bought from you, I think, and I was blown away because, first of all, it was a beautiful instrument, but additionally, once I plugged it in and kind of attached it to some things, it was also extremely playable in a very instrument-like way. Now, You said that you had worked with previous touch-based systems. So like in my past, the one that I think of, I mean, there were two primary ones that I used, which was the TKB, the Surge Touch keyboard, as part of the Surge modular system, but then also the Buchla Thunder, which I had for a while, and drove me a little bit nuts. One of the things I found when I first tried the Soundplane was that it didn't drive me nuts from the standpoint of it tracking the way that I was touching the instrument. And also there was something about the design that sort of like drew out, my guitarist background and stuff like that to be able to interact with it in a very comfortable way. What were the design concepts that you brought to that sort of like ended up creating something that I would consider much more of an instrument than a controller?
Yeah, I think instrument control versus controller is an interesting thing to think about, because we're, ever since people started making music with electronics, really, there's been the ability to divorce the sound generating part of the instrument from the sound controlling part of the instrument, and the sound interacting part, because it also instruments give us tactile feedback too, so that's important. And I guess I wanted to think about it not as much as a technical problem, but also a musical one, and how, of course, a lot of these other instrument designers have done the same thing, but just to approach it in a way that it fulfilled my needs. And when I've kind of sketched that out, it seemed like it might be general purpose enough that other people would be interested in it too. I guess the main difference between the Soundplane and a lot of the things you're talking about is the tactile quality. And so when you push on the Soundplane's surface, even though it's made of wood, it's all these mechanically separate bits of wood that have been they've been separated through laser cut, but they're still joined through various layers of adhesive and things and elastomers inside the instrument. And so when you press on it, there's a very definite give to it over about a millimeter or so. And I worked on that response really hard. I tried at least 10 different kinds of foam in there, and different layers of them, and different thicknesses of them. And the idea is it feels very different. It gives you tactile feedback, unlike something like an iPad app would, and unlike the capacitive controllers that you're talking about.
Right. Well, one of the things that little bit of give, and I have to say it's sort of, the feel of it lives in between sort of like the pressing on concrete feel you get on an iPad versus something real super squishy like a mono or something like that. It's a very subtle give, but it is one where it seems like, especially from a guitaristic standpoint, it seems to have sort of the level of movement that's kind of reminiscent of how you do string bending or string vibrato on a guitar. I found it really interesting. Now, what is the mechanism that's picking that up? Is it watching the physical movement of the wood, or is it actually capacitant tracking of your finger?
So it's a true pressure sensor.
Okay.
It's reading out the forces applied to the surface. So if you put your phone on it or whatever, it'll pick that up. Or you put a rubber ball on it, it'll pick that up. And it does that by internally doing capacitive measurements between a couple of plates. So there's some movable plates, in a sense. They're antennas just behind the wooden surface. And then there's a bunch of springy rubber, and then at the back of it there's another set of metal pickups that are on circuit boards. So the and on the front there's these antennas are flexible antenna material, the kind they use to make circuits in your phone that wrap around or whatever, the bendy stuff,
right.
Flex circuits. And so these are in columns, and in the back the pickups are in rows. So you read it out and you get a matrix. And in the Soundplane's case, the matrix is 8 by 64, I believe that's correct. And so you get a fairly fine resolution, and it's also read out at 1,000 frames a second, which is a lot more than things like iPad and so on. And that's about what that's a case where it actually might have been overkill, I think, in my in just my experience with it, because it turns out you're limited in a lot of cases by how fast the material can move and things like that. But I don't know. It's about right, and that's what a lot of the papers that I read by people I respected, like Matt Wright on the topic, wrote about, that you need around a kilohertz to do a good kind of percussion musical gesturing.
Oh, sure, right. Yeah,
because
I approached it guitaristically, but I can see where it would be very conducive to a percussion-like interaction as well. But yeah, you need really snappy time frames for that.
It's a strange kind of a hybrid in the way it comes to the markings that you're talking about and everything on it, and also in terms of the fact that you can slide around on it freely, but it's giving you a kind of playing suggestion in the form of all these different keys. At the heart of it, it's really just a general purpose sort of X, Y, Z controller, detecting where you put down, any number of fingers. So there's no really need to use the keys. But as the design developed, it seemed like, well, a significant number of people might want the suggestion of frets. And I don't really even have a guitar background myself, but the guitar markings were more of a design solution, because you might want to do things just like with a guitar, like tune a different string, or in the case of a Soundplane, tune a different row to a different interval relative to the other ones. And if you put markings, say, on every row that said, okay, this is now a 5-row keyboard, and there's offset by octaves or whatever, or use some design that microtonalists use for their keyboard layouts, then you'd lock everyone into that. So this is this compromise between complete freedom and between also having something to look at.
Well, and I think that there's some history to that, because not everything with sort of like fret-like markings are necessarily guitar-like in their behavior. If you think of like a steel guitar or a dobro or some of that, very much off of the conceptual basis of a guitar, but not played in that way at all.
Mm-hmm. Yeah, there's one getting played right now by Alessandro Cartini, who's a synthesist and also guitar player. He's been touring with 9 Inch Nails recently with a couple of Soundplane instruments, and I was interested to see what he did. He ended up making some day-glow stick-on, or not day-glow, night glow, luminescent stick-on markings, actually above the whole keyboard, so they're above. He made the same kind of markings, but above the keyboard area, so his hands are never covering them.
Oh, sure.
So I can think about. I'm not in a rush to change anything about the instrument, but as different solutions like that evolve, that I might think about adopting one or more of them after talking to people about it.
Right. Now, when you talk about the creation of the surface and how it's antennas, and you must have had to put together a zillion prototypes to get it to where you had both the feel and the measurable output that you needed. It must have been insane.
Yeah, a zillion is about right. It really took a lot. I still got the first thing I put together out of copper strips, and I was just looking at it the other day because I was cleaning out my closet. Sort of the first working prototype that used this external. The first prototype, there's actually still a video of it on YouTube that I took in 2008 or something when I was finishing up my master's work, and I didn't build any electronics to do it, so it's just got these long cables that run to an external audio interface. But if you have 8 ins and 8 outs that you don't mind tying up with your prototype, then you can send signals out like I was talking about before, and then measure them from the audio inputs. And if you're lucky and it's not too noisy, you can make a working Soundplane with an audio interface. So that's what I started. That's what I did for the initial experiments, and it was handy because I'm not a great hardware engineer, and so I didn't have to build any hardware to do that.
Right. So how now with the current shipping Soundplane, how does it interface with the computer? Is it the equivalent of an audio interface, or is it some other mechanism?
That's a good question. It is so the Soundplane plugs into the computer via USB, and it's just one USB cable, which is pretty important to me.
Sure.
As designer of the instrument. I mean, ideally it would have been no cables, but that wasn't really doable. So the USB provides power, and it also sends information back to the computer. Now, I think maybe what you're asking specifically was, does it look like an audio interface to the computer in terms of the USB protocols and all that? And there was sort of a case to be made for doing that because there's already audio software on the computer, and it might have made our job a little easier. But on the other hand, if you have an instrument and it's something you're never ever listening to the audio of, it seems maybe wrong.
Yeah, it could be confusing to the user, right?
Yeah, or people might plug it in, hear a really bad noise,
right.
as this, if they ended up listening to it. And I've also learned that every audio interface I add to my computer is a possible source of instability and, at the very least, confusion when you're trying to, select between them all if you do a lot of work that way. So
yeah, right on.
Yeah. So we went with a special USB protocol where it does, the Soundplane does, it reads the audio data internally, does a lot of FFTs on it, which is the basic math required to get the pressure measurements out of the device, and then it transmits basically a matrix of the pressure values to the computer. So it's on a real low. It doesn't transmit gestures or anything like that. So it's very agnostic. Kind of learning from David Z's approach of meaningless numbers and from what people do in Max MSP. It doesn't try to impose its own limitations on the data. It just gives you the data. Yeah.
So how then do you interface that data to your audio application, whatever it might be?
Right. Okay. So the data comes in at this fairly abstract level of being a sort of photo, a sort of movie of pressure 1,000 times a second, and that's pretty weird stuff. So there's an application that you run, kind of like what the Monome folks did, that takes this raw data and turns it into MIDI or open sound control messages. And in this application, you can do things like set up zones and say, this zone is an XY slider, or this one is just a 1D slider, or this whole area is going to be mapped to this range of MIDI notes.
Right. Interesting. So now, well, first of all, how available are the Soundplanes? I mean, they look like, when I first saw it, I was like, I was blown away because it has the kind of build craftsmanship of like a violin or something. So, so it's clearly not a mass-produced item. How available are they?
Well, I'm making another run in February, so just next month here. And, maybe this will come back to a discussion of the balance between software and hardware. I've got no desire to make them scarce, certainly, but yeah, I'm limited in my ability to make a whole bunch of them. So there's 50 or 60 out in the world right now being used actively, and when I make another run, it might be 30 or 60 more instruments, depending on how many orders I get. On the one hand, it's not as easy as like walking into Guitar Center and grabbing something, but I think I'm sort of keeping up with demand. On the other hand, there might be some more interest shown now that some artists that more people know about are starting to use it. But that's a problem I'd like to have, and if that happened, I'd probably devote more of my time to making instruments this year. I guess we'll see.
Well, after this call, we'll have to talk about about getting my order in, but certainly having someone like Alessandro visibly using the device is really important. Mm-hmm. Now, simultaneously with the development of the Soundplane, you also developed a plug-in instrument called Aalto. Aalto is where you actually have gotten a lot of attention. So when I perform with a modular synth. Okay. And I'll often show up at some random coffee shop somewhere and set up my little rig. And people come up and say something, I only talk to other people, I think, that are into modular stuff. So only modular people will be at the coffee shop, right? But a lot of people come up to me and say, well, I haven't really gotten into the hardware modular stuff yet, but have you heard of this thing called Aalto? And it comes up a lot, surprisingly. And, certainly if you look at a forum like Muff Wigglers or something, Aalto is a software implementation of a modular sensibility is getting a lot of play. It's the most talked about software on the site.
In that world, it seems really popular.
So what caused you to go from making a hardware thing based off of copper plates to a software modular system that really has kind of, I think one of the reasons people are into it is because it has sort of a booklet-ish sensibility without necessarily being slavish to, historical precedents. What caused you to take a swing at that?
Well, it's kind of a roundabout trip. So I had the idea for the Soundplane coming out of grad school, and where the Soundplane came up in the context of physical modeling. The thesis, I think, was actually called Intimate Control of Physical Modeling Synthesis. So the idea behind the Soundplane, in one sense, being how can we make controllers that make our connections with computer music more like our connections with acoustic instruments. And so I had this project underway to actually build the instrument and get it to people on a small craftsman kind of level, 30 at a time or whatever. And this project I thought would be a reasonable one when I was leaving school if it could be completed in 6 to 8 months or something like that. And of course, in retrospect, that seems sort of ridiculous given the complexity of the project that I know now and all the things I had to learn along the way. So it ended up being 2 or 3 years of work, actually, before the Soundplane was done, which isn't too bad, I think, in retrospect.
Right, but, for a physical instrument, right?
Yeah, but along the way, something had to happen to fund continued development. And I always knew that, I had a lot of sketches for Aalto, basically, on the table, because I knew that some software would have to come out with the Soundplane in order for it to be more approachable. And I had this I mean, I had this idea of what would be a great software synthesizer to use with it. And it seems weird that the first one wasn't about physical modeling, right? But I think that the desire was to make it a more general, first nail the kind of synthetic sounds that a lot of people would want to make with it and maybe be more familiar with, and then get into the physical modeling stuff, which is what I'm working on now. But so Aalto became ready, essentially halfway into the Soundplane project, and allowed it to. It was a success and allowed me to keep on making the Soundplane and eventually make that come out. So it was a roundabout trip, but it all worked in a sense. Right. And both things are still in active development. I'll be coming out with a new version of. I mean, if you look at Aalto, it looks a lot different from the 1.0 version that is almost 3 years old now, and I've got a whole sort of roadmap of planned changes to it, including a 2.0 version coming out sometime this year.
Interesting. Well, one of the things I'd say about Aalto, and I actually use it as a demonstration for people who come up to me and say, hey, I'm kind of thinking about getting into this kind of modular stuff, but, I'm thinking of getting like these 450 modules. And I'm like, well, first of all, good for you for having enough money to be able to do that, at which point they tell me about the debt that they're going to go into instead. But what I suggest to them is that being more creative with a fewer number of modules actually will allow them to explore sort of like the sonic thing a little more completely. And, I always get sort of like this curious raised eyebrow look, kind of the Spock thing.
Right.
And I'm like, and so I will say, okay, there's different ways to approach this modular thing. And if you're coming to it from like a Max or a Reactor kind of view of modular work, there's this sense that I have to have an almost infinite number of everything in order to be able to accomplish all the things I might want to do, right? Mm-hmm. But when I show them Aalto and I show them sort of like how that environment works and kind of explain the idea that instead what you have is you have this kind of limited thing, but where each item has very broad usefulness or usefulness in many different ways, you can kind of see them say, oh, it doesn't, to have a workable modular system doesn't require, 400 things. What it requires is a few things and a little bit of savvy in making them interact well. And the savvy comes from playing with modulation amounts and playing with the edges of some of the things. And I find that the Aalto system really has interesting edges. How, from your perspective, when you were putting together the design, obviously you had to make choices about limits, and coming from a background where you had access to either, raw code or things like Max, how did you make the decisions, or how did you come up with decisions that said, hey, a sequencer like this, or, an oscillator count of this, or a noise source that does this, that's sufficient for getting work done? How did you make those decisions?
Wow. Well, that's an interesting question. And it's funny. I think I should start by saying I've had a lot of synthesizers, but I've never actually had a hardware modular one. I've probably tried most of the different connections you could make on the synthesizers I had. So I've had a few things like an analog sequencer and a couple of SH-101s that you could do weird things like plug in the CV of one to the gate of the other and vice versa and make kind of strange chaotic loops with them. But I never had a panel with different modules in it all facing one direction. And So maybe my design was happily, unhampered by some of the conventions that people use when they're in that realm. Certainly, I've done a lot of work with Macs, and so that gave me a laundry list of both things I kind of did and didn't want to do with my own setup. And then there was, I never had a chance to operate a Buchla music easel, but that was definitely an inspiration, because what you're talking about, this gets kind of heady, but there's a great sort of definition of art or of complexity in expression that I think comes from Christopher Alexander, the architect. And the idea is basically, if you're taking one system, let's say in the context of a poem, why is a poem different from a sentence in a newspaper, right? But one reason you could say is in the poem, the words have ambiguous meanings, which say they also kind of simultaneously embody multiple meanings, right? So you have to go into it and tease it out. And when you're designing a thing, so Alexander talked about this in the context of a building being good in the way that a poem is good. So one part of your building might not just be useful as a column that holds up the roof in a certain place. It might also be a nice shade structure. And so when you start thinking about design with that idea in mind, you think, well, how could my oscillator be also, a shade structure? Or how could my sequencer be? And so, if you use an analog sequencer, you can turn it up and it becomes a pretty good oscillator too.
Right.
So, and with its own characteristics. Buchla definitely took advantage of unhampered by convention worldview, I think, into some of his designs, and a real design sense of this kind of multiple meanings. And I was trying to let those inspirations guide me.
Right. So now, as if the things you've done haven't been difficult enough already, with an upcoming project, you started, I think, to show this. You showed it at Decibel and a couple of other festivals. You've done little tidbits of information here and there about your next software product, which is called Kaivo, correct?
Mm-hmm. That's correct. K-A-I-V-O. Okay. Folks at home.
Yeah. And this is going to be sort of like Aalto for physical modeling, I guess, right?
Mm-hmm. Yeah. So the interface from Aalto the interface from Kaivo keeps the basic setup from Aalto that people seem to like, and most of the sound making apparatus is pretty different. So instead of fairly simple equations for things like filters and envelopes and oscillators, it's running a lot of physics equations in real time that model vibrating objects like strings and pipes and even 2D vibrating surfaces, and then reading out the numbers from those equations and playing them as sound in real time. And this is, this kind of idea of synthesis has been around for a while. There have even been a couple commercial products, like there was the Yamaha VL1 synthesizer, I think, which is some incredibly expensive late 80s or early 90s thing.
Right.
And I might have the time wrong there, as I so often do, but it was definitely expensive and not sort of a flagship, not widely used thing. And there have been a few other synths based on it, and it gets used here and there, but I'm not sure why it's not more widespread. It seems like a good area to do to put out some work I'm interested in. So
the two places where I've interacted with physical modeling myself was, first of all, both working with Perry Cook's original published algorithms, as well as the thing that he and Luc Dubois did for, was it called Percolate, I think, was the objects that they had that ran in MSP. But then
that sounds right.
Yeah, and then also Applied Acoustics had the Tasman software.
Yeah.
But in both of those cases, what I found was that it was difficult for me to find a musical way of using it. I could make tremendous noises, right? But I was not able to very often find things that were musically satisfying. And I think I must not be the only one with this case, because Tasman or Applied Acoustics subsequently sort of like instrumentized some of their stuff to make it more, so now it's like, here's an analog model, or here's a bang on a can model, and here are all the pieces that turn it into an instrument-like device. So, on the one hand, if physical modeling is presented as a completely open-ended thing, it can be hard to really grasp the musical use of it. Conversely, if it's completely wrapped up into this is a model of X, it seems like it kind of constrains it to the point of it's just sort of like sampler plus,
Exactly.
And my question is, given how you to me, Aalto was an interesting way of taking sort of like an analog model, conceptual model, and finding a really unique way of making it musical, but also very expansive. How do you do that same thing with physical modeling?
I guess I'm trying to figure out how to do it almost as we speak. I mean, I'm about to get the first beta out of Kaivo, and it's going to be real interesting to hear what feedback people have about it around this very issue that you're talking about. Physical modeling has a fairly well-deserved reputation for being this form of synthesis that's sort of hard to control, because there are often these huge parameter spaces where, and they're huge multi-dimensional parameter spaces. So you've got maybe nine dimensions that you're trying to control together, and if all the knobs are just in the right place, it sounds like a piano for a second, and you turn one of them just too much, and then it all flies apart.
Right.
So my goal into making it accessible, making it more user friendly, is to identify these little islands in the parameter space, and then put labels on them. So say, okay, you change the mode menu for the resonator, and it puts you in, let's say, the piano-like space, and then to find reasonable combinations of those parameters that are musically meaningful somehow, so you can go from there. So that's the kind of stuff I've been doing and will be doing over the next month more. And it's fun because it's really it's easy to get lost in.
Sure.
If you have a task on your to-do list, like finish the labels on the knobs, when that's done, but it's really hard to know when something sounds acceptable for release when you've got a limitless ocean of possibility ahead, right? Where do I draw the line? So that's hard for me sometimes. So it's hard because it's super fun getting lost in these spaces and just listening to sounds and thinking, wow, this is my work. It's great. But it's I have to then rein it in. At some point.
So how did you personally get drawn into the physical modeling world? Was it part of your study, or is it just something you tripped over that you found pretty fascinating?
Where did I first encounter? Well, I've always been kind of a synth head and trying to be on the lookout for new things. So I'm sure I was aware, probably from some long ago Keyboard magazine article, maybe, that physical modeling existed as an idea, and probably tried writing a carpless strong string by reading about it in Computer Music Journal at some point. But I guess it seemed when I was, it really comes back to the thesis topic again, and playing around with people at the laboratory at UVic and thinking, well, how do I find interesting problems in the area of computer music to do something about or say something about? And this connection, this loss of connection between the body and the sound seemed to be something, maybe if you were to ask me what's the most unsatisfying thing to you about a lot of current computer music performance, it would be that. So the idea of physical modeling seemed like a natural marriage to a controller that was very sensitive at picking up what your body is doing, because at least you could start to think about, it's by no means the only thing to try, but if you have a model of vibrating object, you can think, well, how am I going to hook the surface up to it? And I can do things by hooking the surface up to it that make sense in the metaphor of the synthesis itself. And so maybe that will provide, playing experiences that have a kind of that come from people's understanding of the natural world somehow, and how normal objects respond when you bang on them.
Sure. Well, man, this is fascinating, and I'm really anxious to see Kaivo in action, because if it has sort of like the personal resonance that Aalto and the Soundplane have, I don't know, you seem to have sort of like a unique insight into my soul or something, because I find your work really compelling and very inspirational. I really want to thank you for the time that you've been able to spend with us this morning. And we certainly will keep in touch. Maybe after Kaivo's released, we'll have a follow-up interview or something. But otherwise, I just want to say I really appreciate your time and appreciate the fantastic work that you're doing.
Well, it's been my pleasure. Thanks for the good questions. Nice talking to you, too.
All right. Have a great day, and I'll talk to you soon.
Okay. You too, Darwin. Bye-bye.
Bye. Okay, and there's another one for the books, another great interview. Randy was so cool to be open, not only about his how he does the things he does, but some of his design decisions and some of the decisions about running a small company as well. I want to thank him again for spending the time with me, even though we both sounded like we were on our deathbeds. Next week is going to be a really great interview with Liz Larson, one of the owners and chief designers at LZX Industries, which does hardware-based video synthesis. It's really cool stuff. Hope you'll join me then. In the meantime, have a great week, and I'll talk to you soon.